Hi, it's Mr. Ahmed Az, math teacher for middle and high school, and this is a demo lesson. I choose a lesson for grade 9, relations and functions. The main objective in this lesson is analyze relations and functions, and this designed by me. I will start by the breaking the ice. Breaking the ice is an activity in the beginning of the year. Um I let the student to choose a paper and write something that he likes, something he don't like, he doesn't like, something one thing personal. Exchange. They will exchange with their partners. Tell the names of their partners, and then I will start my lesson. This is the beginning of my presentation. At the beginning of my presentation, I will use think, pair, share activity. Think, pair, share activity is an activity with the visible thinking routine. So it will be a routine for the students. I will discuss for them and explain how can they think individually for each student. Then each student will pair with his partner. Then they will share the answers with the same group. I will show them an example of how to locate the points on the coordinate plane using the coordinate plane x-axis and y-axis. They can find the location of the point. It's so easy for them. They studied this at grade 6, 7, and 8. Using the guide of example number 1, they can solve the exercises here. Number 1A, B, number 1, 2, 3, 4, 5. They can determine the location of the points A, B, C, D, and E on the graph. And also about the quadrant of each point, that is the location of each point and the quadrant of each point. The second concept I need before starting my lesson is how to evaluate the expression. This is example lesson number 1, lesson 1.1 we studied before. Evaluating 3a squared minus 2ab plus b squared if a equals 4 and b equals -3. It's so easy for them to evaluate using the order of operation. They will replace the variable or the letter by the number. 3 times 4 squared minus 2 times 4 times -3 plus -3 squared. They will start to evaluate the exponents first. 4 squared equals 16, -3 squared equals 9. Then multiplication, 3 times 16 equals 48. 2 times 4 times -3 equals -24. Finally, the answer it will be 81. They can do it here by the same method. And the third concept that I need before starting my lesson, how to solve the equation for a given variable. The given variable in this equation here, solve for y. They will try to make the variable y in a unique side here. 3x plus 6y equals 24 by subtracting both of the two sides. Minus 3x here, minus 3x here will be 6y, dividing by 6 in both of the two sides. Then y finally equals 24 divided by 6 equals 4. 3x divided by 6 equals half x, and then they can simplify. They can do it from exercise number 12 till exercise number 16. Now, I will show for the students a picture, and I need them to write in the paper what do they see just describe the picture that you see. I know that it's a funny picture, but I need you to think deeply in the picture and write what do you think about the picture. Then I want you to write what do you wonder about the picture. I want you to write the questions that's going on in your mind about the picture. Now it's my turn to explain what is the function, what is the condition that I can say the relation is a function. The function is a relation between two sets. The first set maybe it's called x and the other one is called y. X maybe is an input and y is output. The set of x has elements 1, 2, 3. The set of y has elements number 4 and 6. As we see here, number 1 is paired with number 4, number 2 is paired with number 4, 3 is paired with number 6. The condition here is each element of the set of x has only one image in the set of y. But it's not a function. This is a relation between two sets. Number 3 is paired with number 2, and in the same time, it's paired with number 1. Therefore, this is not a function. This is a normal relation. I can represent a function using an arrow diagram. This is called arrow diagram because this is arrow and another arrow and another arrow. And I can represent the function using the set of ordered pairs like that, 1, 4, 2, 4, 3, 6. I can represent this function using a graph, maybe a curve, maybe a straight line, as we will see in the next in the examples. And that is the key concept of the functions. Now, I said the function is a relation between two sets. The first set is called the domain, and the other set is called a range. I can say this is one-to-one function if each element of the domain pairs to exactly one unique element of the range, like that. 1 with D, 2 with B, 3 with A. This is a function, of course, and this is one-to-one function. But here, this is not one-to-one function. Yes, number 1, this is a function, but number 1 is paired with D, number 2 is paired with B, number 3 is paired with C, number 4 is paired with C. This is not one-to-one function because there is two arrows is coming. One of them is coming from 4 to C, and the other one, 3, is coming from 3 to C. They get the same answer in the range C. In this type, I will say this is onto function. The onto function, each element of the range corresponds to an element of the domain. But this is not onto function. This is not onto function because the element C, the element C doesn't pair with any element in the domain. Finally, I can say this is one-to-one and onto at the same time, both of one-to-one and onto function, if each element of the domain is paired to exactly one element of the range, and each element of the range corresponds to a unique element of the domain. Example number 1 will show how can I apply the key concept of the lesson by using the example. This form is a set of ordered pair form. I want you to state the domain and the range of each relation, then determine whether each relation is a function. If it's a function, determine if it's a one-to-one, onto, both, or neither. To help me solving this question, I will draw an arrow diagram to make it easy for me. Yes, arrow diagram, one box for the element x, the set of x, sorry, and the other one for the set of y. I'm sorry, I don't have a device that I can use my pen to write on it. I'm using my laptop. I will write the elements of x and the elements of y from the ordered pairs. The first coordinate, as you know, represent the x coordinates. We'll write here directly -6. Here -6. Here is -5. Here is -3, -1, and 6. The elements of y, -1, -9, -7, 7, and number -9, I will not repeat it in the set. And this is a concept. We don't repeat the elements. We don't repeat the elements in the same set. Now let's join. I will join number -6 with number -1 according to the given. -5 with -9, -3 with -7, -1 with number 7, number 6 is paired to -9. Now, this is a function or not function? The answer, of course, this is a function because each element in the set of x is paired with element in y. That's it. This is a function. This is one-to-one. Of course not. This is not one-to-one because I have number 6 is paired with number -9. Number -5 is paired with number -9 too. This is not one-to-one. This is onto. This is onto function. Yes, this onto function because each element of the range is paired with the elements of the domain. Nice. Now it's easy to determine if this is a function or not, if it's a one-to-one, if it's onto, using the arrow diagram. If I have the form of the set of ordered pair. But what if I have another form? Another form for the function using a table. If I have a table here, I can make an arrow diagram by the same method, and I will make the same exactly using the arrows and know if there is each element in X has only one image in Y. Number 2, it has the image of -2. Number -1 is paired with -1. -2 is paired with number 0. Number -1 again is paired with number 1. Now, number -1, it has two images. It has two images. The first image is -1. The other image is number +1 in the range. Of course, this is not a function. Yes, this is not a function because the condition of the definition of the function is not applied in this exercise. The same exactly in number 2 and the number 2. Yeah, number 2, it has the image of number 2 is -2. The image of number 2 is number 2. Of course, this is not a function. Now, this is check the concept for the students. A quick check. The same question. This is a function or not function. This is one-to-one function or not, onto, both, and so on. Number B, I think it will be easy for the students to get it. Yes, this is a function. Each element in the domain, there is one arrow is coming from each element in the domain, and there is not one-to-one, because there is a number 6 here, number 6 in the range. It's paired with number -1 and number 1 in the domain, of course, and it's one-to-one. Of course, it's not onto, it's neither one-to-one, not onto, because number 8 here, number 8, it doesn't pair, it is not paired with any element of the domain. For the graph, it's another form of the function, a graph, instead of the arrow diagram or the table or the set of ordered pairs, but we can put the set of ordered pairs on the coordinate plane. If the students here they are struggling by the graph, we can learn how can I determine this is a function or not a function using a vertical line test. The vertical line test is helping me this is a function or not. If the vertical line cuts the curve of the function in one point only, therefore this is a function. But if I draw here the vertical line here, and cuts the curve of the function in 2 points or more than 2 points, therefore this is not a function, according to the definition, of course. Here I can use the test concept check here for the students. Concept check for the students, they can use the vertical line to check if this is a function or not by using the vertical line test. 1, 2, 3, all of them, just only the vertical line will cut just only 1 point in each one. 1 point only, 1 point only for all of them. Therefore, this is a function, of course. This is a function. He has another question. Is the relation discrete or continuous? The discrete, yes, this is a discrete function because each element, it's individually elements. They are not connecting. If I connect the points on the graph, therefore it will be a continuous function. But this is a discrete function. The next, after the concept check, I will explain for the students the relations and the equations. This is another form of the relation by using the equation. I can write the equation. For example, I have the equation y equals half of x minus 3. Number 1, I want to learn how to graph this function. Then from the graph, I can determine this is a function or not. I can find the domain and the range of the function. I can know this is one-to-one or onto or both or neither. I can state this is a discrete or continuous function. Let's start. How can I graph the function? How can I graph the function? Step number 1, I will construct a table. The table consists of x and y. We'll choose some numbers for the values of x. I choose some numbers here, -4, -2, 0, 2, 4. and I will use the equation which represents the relation y equals half of x, which means 0.5 or 0.5x minus 3. Then I will replace each x and put its value from the table. When x equals -4, 0.5 times -4 it will be -2, -2, -3 it will be -5. 0.5 times -2 it will be -1, -1, -3 it will be -4. Replace x and put 0. 0.5 times 0 it will be 0, 0, -3 it will be -3. 0.5 times 2 equals 1, 1 minus 3 equals -2. 0.5 times 4 equals 2, 2 minus 3 equals -1. After constructing a table here, I will put the ordered pairs on the graph, the coordinates plane. The first point, -4, here from 0, from the origin point, -4 to the left. Then -5 down, here will be the first point. The second point, -4, -2, -4. Third point, 0, -3. The fourth point, 2, -2. The fifth point, 4, -1. After finishing that, I can say this is a function or not function. Of course, this is a function. And if I use the vertical line test here, the vertical line test like that, any vertical line, it will cut here, it will cut the curve or the straight line of the function in one point, just only one point for each one, not more than 1 point. Okay, this is a function. The second one, what is the domain of this function? As you see, this is a straight line, goes to the right, goes to the left, goes up, goes down, goes to the right, to the left. That means it's all the real numbers. Up and down, all the real numbers. The domain represents all the real numbers. The range represents all the real numbers. This is 1 to 1, yes, 1 to 1. It's onto, yes, it's onto. Why 1 to 1? Because it's just only for each element here. For each number in X, just only it has a different answers. For each input, it has a different output. There is no element here in X which doesn't pair with the coordinate Y. And that, another question, yes, he asked about this is a continuous or discrete function. Of course, this is a continuous function because this is a solid straight line without any breaks. This is a continuous function. And now the concept check or the independent practice. I can use the same activity, think, then pair, then share. They will think together, then pair with their partners and share the answers in the same group. Now, I will close the lesson using chalk talk activity. The chalk talk activity is a silent activity, an opportunity to have a conversation in writing. Just only they will write what did they learn today. They can write everything that they learn, the meaning of the function, one-to-one function, onto function, when the function is one-to-one and onto, the domain of the functions, the range of the functions, how can they graph any function, how can use the vertical line test to check if this is a function or not, This is a chalk talk activity using a chart for each student. For each student, they will write and make comments for each other on the charts. Thanks and good luck.